In this lesson, we will study blessus, the protoliths of the three major rock types, metamorphic, igneous, and sedimentary rocks. The new rock, formed through profound changes in the solid state under the influence of high temperature, high pressure, and chemically active fluids, is called metamorphic rock. Metamorphic rocks are mainly composed of residual minerals and metamorphic minerals. Residual minerals refer to the original minerals retained from the protoliths. After metamorphism, such as quartz, feldspar, calcite, and dolomite. Metamorphic minerals refer to minerals newly formed during metamorphism, such as garnet, talc, and serpentine chlorite. These minerals are all characteristic of metamorphic rocks and can thus serve as indicator minerals for metamorphic rocks. Metamorphic rocks have three major structures. The first type is the crystalloblastic texture, which refers to a crystalline structure formed by the simultaneous recrystallization of minerals in the protolith under solid-state conditions. Its crystalline grains are clearly visible to the naked eye, such as marble. The second type is palimpsest structure, which refers to a weakly metamorphosed rock with incomplete recrystallization, where individual grains are difficult to distinguish with the naked eye, and some original structural features are preserved, such as slate. The third type is cataclastic structure, which refers to a structure formed when minerals in rocks are bent, fractured, or even crushed into fragments or powder under directed pressure and subsequently rebonded. The main types of metamorphic rocks are contact metamorphism, dynamic metamorphism, and regional metamorphism. Contact metamorphism is also called thermal metamorphism, with temperature range of 150 to 800 degrees Celsius. The process below 150 degrees Celsius is termed diagenesis, whereas above 800 degrees Celsius, many rocks reach a molten state, a condition clearly incompatible with the premise that metamorphic rocks time. Dynamic metamorphism refers to the metamorphic process in which rocks undergo recrystallization under intense directed pressure, resulting in the alignment of mineral grains and the development of foliation, a characteristic structure of metamorphic rocks. As shown in Figure A, in the absence of stress, the minerals in the rock are arbitrarily distributed, as shown in Figures B and C. Under the action of directional pressure or shear force, the minerals in rocks are distributed in a directional manner. Regional metamorphism refers to a type of metamorphism caused by temperature, pressure, and chemically active fluids, and other multiple factors. It occurs over extensive areas, spanning thousands to tens of thousands of square kilometers, and can affect depths exceeding 30 kilometers. The two most typical structures of metamorphic rocks are schistose structure and massive structure. The schistose structure refers to a specific texture formed by the parallel alignment of minerals under directed pressure. Slate, phyllite, schist, and gneiss are typical rocks with schistose textures. From the top down, the degree of metamorphism gradually increases, accompanied by progressive enhancement of recrystallization. Marble, quartzite, clastic rock, and mylonite are all typical massive rocks. Marble and quartzite belong to contact metamorphism, while cataclysite and mylonite belong to dynamic metamorphism. Next, let's know these metamorphic rocks together. Slate is formed by the low-grade metamorphism of its protolith. The mineral grains are fine-grained and compact, making them difficult to identify with the naked eye. The rock splits easily into thin slabs and can be processed into roofing slates of various sizes for use as a building material. With very low permeability, it is suitable as a water-resistant layer. Phyllite is primarily formed by the low-grade metamorphism of claystone, with thin schistosity, and its mineral grains are generally indistinguishable. Only on the schistose plains can a pronounced silky sheen be observed. The rock is soft in texture, has low strength, and is prone to weathering and spalling, often leading to slippage along the schistose plains. Schist is a medium to high-grade metamorphic rock, predominantly composed of micas and quartz, with feldspar being generally rare. Recrystallization is obvious. Schistose and massive minerals are enriched along the schistose plain, with the schistosity being very thin and easily separable into irregular flakes. The rock has low strength and poor weathering resistance, making it highly susceptible to weathering, spalling, and even slope failure. Gneiss is a high-grade metamorphic rock with a granuloblastic texture characterized by coarse-grained crystals and composed mainly of quartz and feldspar. Therefore, the presence or absence of feldspar is an important criterion for distinguishing between schist and gneiss. The gneiss exhibits a black and white banded structure with intermittent continuity, characterized by high strength, suitable for use as a construction material. Marble is a metamorphic rock derived from limestone, named after Dali in China's Yunnan province, where high-quality varieties are abundantly produced. It is also known as white jade. The mineral composition is primarily calcite, which reacts vigorously with dilute hydrochloric acid, producing effervescence. Consequently, the rock exhibits solubility. Quartzite is a metamorphic rock formed from quartz sandstone, primarily composed of quartz, with a content exceeding 85%. It is characterized by its hardness and strong resistance to weathering. Next, let's examine a specific case, the awe-inspiring cliff corridor. For centuries, the villagers of Guoliang were connected to the outside world only by a precipitous sky ladder, virtually isolated due to the treacherous mountain terrain. In 1972, Shen Mingxing led 12 villagers in a 6-year struggle, carving out one 300-meter-long, 6-meter-wide, and 4-meter-high passage through a 120-meter-high quartzite cliff using sheer sweat and sacrifice. This cliff corridor is hailed as the 9th wonder of the world, a testament to quartzite's remarkable hardness. The last two metamorphic rocks are all formed through dynamic metamorphism. Clastic rock is composed of crushed fragments of rock. The composition and structural characteristics of the protolith's composition and structural features are partially preserved. Myelinite consists of finely crushed rock particles, with the protolith's structure and texture completely destroyed, making mineral identification difficult with the naked eye. In this lesson, we learned the definition of metamorphic rock and mineral composition, structure, and construction. Next lesson, we will enter RAN, geological structure, and learn of reading geological maps.